So let's get started. Good morning, guys. Starting from this class, we will go to the second part of our course. As I said in the syllabus, the second part of this course includes the introduction of basic elements and basic concepts of information system and database. So the very first question is that what is information system? What is database? And what is the difference between database system and the Excel system that we learned before? Well, let's take a look. In the database system, in this course, I will use Microsoft Access as a database system management system to manage the data in the database system. Okay, let's take a quick look. This is a sample database system opened in Access. And in Access, we can see a lot of different tables, including the records that you need. For example, in the cache table, well, we can see no records in this table. It's a null table. But in this table, there are several fields. First field, that is account number, bank name, bank account number, and balance. But there's no records in this system. And in the second table, collections table, we can see there are 5 fields. Oh, 6 fields with only 1 record here. And let's open more tables. For example, context table. Well, as you can see, there are 5 different records, and there are 4 different fields in this table. In addition to tables, there are queries and forms. Well, these 3 elements, tables, queries, and forms, are 3 basic elements provided by Access, which is the database management system that we will use in this course. Well, as you can see, it is very similar to Excel. This is the Excel spreadsheet that we are using. Well, for example, in this spreadsheet, there are 5 worksheets. And in this worksheet, for example, you can see a table which ranges from A3 to E14. Well, this table is very, very similar to the database, as you can see in Access, in the Access file. In this table, there are 5 fields and several records. But in this worksheet, in the whole worksheet, it is a little bit different from the database system. Well, because you can see a title here and several records based on calculation, which is listed right under the table. And this area has a different structure with the main table, because as you can see in the main table, there are 5 fields and several records listed in rows. But in this area, as you can see, there are 4 information elements, only 4 information relevant elements, but listed in only columns. Well, in the database system, you cannot do that. It's against it. It's against the good design principles of database system. But why it's against the design principles of database system? Well, regarding this point, I will explain it in later chapters. Well, the biggest difference between the database system and an Excel worksheet is that the database system can be shared. Well, actually, almost all the information stored on the internet, provided on the internet, is stored in the database system instead of Microsoft Excel spreadsheets. Let's take a look at this example. You guys are all Rutgers students, and these 2 systems, I believe, are the most commonly used system for you. One is Canvas, and the other one is the portal, My Rutgers portal system. Well, admittedly, these are 2 different systems, where Rutgers portal provides the basic information, personal profiles management, and Canvas system is a web-based learning management system where you can share the course-related contents with instructors and the students. But when you log into each of the systems, you need to click login. Well, this is the Canvas system when you click login. Well, let me log out first. Log out. When you click login, let me open another page. This is Canvas system. When you click login, it directs you to this web page. You need to you need to provide your net ID, net credential to log in. And in the portal system, when you click login, it directs you, as you can see, to the same page for identification recognition. Well, actually, these two systems directs you to the same page. Well, actually, your credential information is stored in the central database managed by Rutgers that stores all your credential information. All of the login steps directs you to this page to for your identification recognition. But if your username or password are stored in the Excel spreadsheets, it is impossible for these different systems to get the data from the Excel worksheet because there are no interactions between Excel spreadsheets and different web-based systems. Well, again, these web-based systems are based on the database system to share the credential information of each student at Rutgers University. So this is the very first chapter of information system and database system introduction. So in this chapter, we will discuss the basic elements of computerized information system. First, we discuss the differences between data and information. Then we will discuss how data are organized in computer system at the most basic level. Then you will become familiar with alternative field formats and records. Thereafter, the hierarchy of data from bytes to a database is presented. Fields and the various types of files will also be discussed. Then we conclude this chapter with a discussion of a system approach and an explanation of what that entails. So first of all, data and information. I believe these are two concepts that you heard almost every day in your life. But what is the difference between these two terms, data and information? Well, data, first of all, data represents raw and unprocessed facts that are useless without further processing. But information is data made meaningful. The information system processes data to render useless factor into useful information. For example, if you walk from door to door to every residence in your city and record the names and phone numbers of all the residents in the order of your visit, you would have an extensive collection of data. But these data are essentially useless, since it would be very difficult to locate the phone number based on the resident's last name. What converts this data into meaningful information, namely a phone directory, is the process of alphabeting the data. That is, if names and phone numbers are sorted in order of the last name of each resident, then the data becomes meaningful. The sorted list is useful, since it is now possible to locate the phone number of any resident so long as you know the last name of the resident. Information alone is only a means to an end. The right information delivered at the right time and interpreted in the right manner can lead to knowledge, and knowledge in turn can lead to wisdom or even power. And an excellent example of information versus knowledge, wisdom, and power is the internet. There are trillions of megabytes of information on countless homepages on the websites, but only few of us obtain knowledge about a particular topic from the internet. Fewer still can convert that knowledge into wisdom or power. The data to power value chain. This value chain, also referred to simply the information value chain, is shown in this slide. For information to be truly useful and meaningful to a user, it must meet certain qualities. It must be relevant, reliable, complete, timely provided, understandable, and verifiable. First, it must be relevant and reliable. The relevance of information pertains to its ability to assist a user in making a decision. For information to be relevant, it must be received in a timely manner and must have a capacity to change the user's decisions. It must be made available soon enough to make a difference and must make the user better off relative to his or her situation prior to receipt of that information. Reliability of information has to do with its accuracy and freedom from errors. Information replete with errors is unreliable and can potentially lead the users to an incorrect decision. Control mechanisms must be placed with the information system to prevent intentional and unintentional errors in data input, processing, or information output. A concept closely related to reliability is reproducibility, using the same data as input and applying the same processing methods. Another information system should generate identical information. So in summary, data represents raw facts, whereas information is the data made meaningful. Information must be both relevant and reliable to really be useful to a decision maker. So next, let's explore how data are sorted in computer-based information system. Well, at the lowest level, all computer systems store data in the form of bits. A bit in the computer system is actually a 1 or 0. A bit is a binary digit that can take a value of either 0 or 1. Well, in a sense, a bit is turned on by a tiny electrical impulse and is turned off when the impulse is discharged. Actually, there are millions of or trillions of such electrical impulse inside the computer system. A group of bits forms a byte, B-Y-T-E, byte. And in the computer system, 8 bits form a byte. A byte is roughly equivalent to a character, such as the letter A or the number 3, which is the lowest element understandable by humans. A group of related bytes forms a field. Well, for example, as I said, 8 bits forms a byte. So here is the binary chart that shows the relationship between each different character of different bytes. For example, the name John, J-O-H-N, is represented by a computer system like this. Well, inside the computer, all information is stored in a binary level, either 0 or 1. So, for example, the character J is stored in the byte as 010010110, and O, H, N are stored in other different sequences of bits. So this is how the letters are stored in the computer system. And as I said, a group of related bytes form a field. Thus, the group of bytes that forms the word John make up the name field. And the group of related fields makes up a record. For example, Tom Jones, Marketing Sales Associate, September 1st, 1907, $2,500. It's a group of fields which make up an employee record, showing the employee's name, department, grade, date hired, and monthly salary. That makes up a record in the database system. Well, let's take a more straightforward look. Let's take a look at this database system. In this table, for example, there are 4 fields. 1, 2, 3, 4. The first field is contact number. The second one is EID, or let me see, the employee's ID. Third one, CNO, which is customer's number. And the last field, date contacted. And as you can see, there are 5 records in this system. So these are fields and records. And let's go to further. A group of logical records constitutes a file or a table in the database system, and a collection of logically related fields is a database. All files relating to, for example, Division A's operations would constitute a Division A database. So, as shown in this slide, the hierarchy of data starts with bit at the lowest level and ends with a database at the highest level. In creating an information system, a number of design decisions must be made relating to fields, records, and files. So now, let's see the various options related to fields, records, and file design. Field format. The format designated for a field is one design decision that you might be involved in. Although the field format decision is usually not irreversible, giving some forethought to the kind of data that might be stored in each field is time well spent. Back in the late 1990s, a lot was made by the year 2000 problem. refer to the computer speak as the Y2K problem. When establishing the field formats and length of fields in many of the older computer systems developed in between 1960s and 1970s, no thought at that time, no thought was given to the implication of the year 2000. Well, at that time, the old programs were written primarily in COBOL language, which didn't have a date format at that time. Dates were simply stored as a string of 6 characters. Their month, date, year. Well, only 2 digits stands for the year. Thus, these programs stores only last 2 digits of year. This was done to save storage space, which was at a premium in those days. As a result, these computer programs would have interpreted the year 2000 as 1900. So, performing enormous calculations in a host of applications, such as those computing interest on loans, premium due on insurance policies, aging accounts receivables. It's the old computers encountered this problem. The millennium bug, as it was referred to, was hidden with trillions of lines of COBOL code in the computer system of most large organizations. It is estimated that the industry-wide fix for this problem cost over $100 billion. Perhaps this was the money well spent, since there were almost no Y2K related problems as organizations moved from 1999 to the year 2000. Well, most computer systems support the following formats: numeric, text, currency, datetime, and Boolean. Some systems also support counter fields and fields capable of storing binary objects, such as multimedia files. For example, the image, the video clips, and sound recording. Let's now understand each of these fields. First, as the name suggests, numeric fields can store only the numbers. And in contrast, text fields can store any keyboard characters. Moreover, these text fields can store any character in the complete character set used for a particular computer. All the characters in the character set for a computer are called alphanumeric, while currency fields are used for storing dollars and cents formatted dollar and cents formatted field. Date and time, as you can see, store the dates or times in a variety of user-specific formats. Boolean fields can hold only one or two possible values, either true or false, or in some computer systems, they are stored as yes or no. Counter fields are automatically incremented by 1 whenever a new record in the field is created. Well, these fields can be used in the coding system. Sequence coding system often uses this type of fields as the primary key of different records in the database system. Well, but what are the primary keys? What is sequence coding system? These two concepts will be introduced later on. And lastly, let's see the blobs. It stands for binary large objects. They are used to store multimedia files. For example, the pictures, sound recordings, etc., etc. Okay, I just introduced one concept, primary key. So, in addition to primary key, there are other types of record keys. And now let's see what are they. In addition to selecting appropriate formats or fields in a record, another critical design is the designation of primary key for a record. The primary key is the field or set of fields that uniquely identify the records in a file. Well, for example, in a student file, the student ID number could serve as the primary key because every student would have a unique student ID number. In most files, the primary key is obvious. Customer files typically have the customer number field, which would be the primary key. The sales invoice number would be the primary key in the file of sales invoice. It is possible for a file to have more than one unique identifiers. For example, if a student file stores each student's assigned student's ID and the student's social security number, then that student file would have two unique identifiers. And each of the two unique identifiers is called a candidate key. Candidate key. Since each is a candidate to serve as the file's primary key. However, only one of the two unique identifiers must be designed as the file's primary key. Or in other words, only one field must be designed as the search criteria for the file. Well, some files may require more than one field to uniquely identify the records in the file. Let's consider a file used to store customer complaints. Assume the customer number of the customer who makes each complaint is recorded. In addition, the date and time of that complaint is also recorded. But no separate complaint number is generated, assuming a customer could have more than one complaint. Then the customer number alone would not uniquely identify the records in that file. But if we assume that a customer number will not have more than one complaint in a day, then the combination of customer number and date, these two fields working together, would uniquely identify the records in a complaint file. If we assume the customer would have more than one complaint in a day, then the combination of these we can see 2 or 3 fields. They are customer number, date, and time, would uniquely identify the records in a file. When the combination of fields is needed to uniquely identify records in the file, well, in this case, the primary key is called composite key, or a concatenated key, composite key, or concatenated key. Some computer environments feature system-generated identifiers for files. Well, if you can recall the counter field formats as I just introduced. Counter field formats, which is automatically incremented by 1 when a new record is added to the file. In effect, the counter becomes the system-generated primary key for each file. The counter is simply numbered beginning with 1 and ending with the number of records in the file. Depending on the coding scheme used in the system, the primary key can be used to reveal many different aspects of records in the file. Coding schemes are later discussed. The fields or attributes in the file that are not part of the primary key are referred to as non-key attributes. One or more of the non-key attributes in the file can be designated as secondary keys. while primary case uniquely identifies the records in a file. Secondary keys are used to sort the file in some sequence, or for reporting purpose, or to answer user queries. Consider a file of sales invoice with the following fields: invoice number, date, customer number, salesperson's number, sales region, sales amount. Okay, these fields again: invoice number, date, customer number, salesperson's number, sales region, and sales amount. In this file, the primary key is the invoice number. Each of the remaining fields is a potential candidate for being a secondary key. Secondary keys are used to sort the file to respond to a user request for information. So, the sales manager might want a listing of sales invoice by date, by salesperson's number, or by sales region. These requests could be handled by sorting the file by each of the relevant fields. Indexing. Indexing the file on the field can make sort operations on the field, and the selection of specific records based on the fields considerably faster. Indexing will be discussed a little later in this chapter. Well, so this slide is a summary of the record case discussed above. So next, let's focus on primary key. Well, in discussing primary keys, we alluded to the process of establishing a coding system. There are three types of coding systems. They are sequence coding, block code, sequence code, block code, and group code. Three coding systems. And as you can see in this slide, there is an extra coding system which is called Mnemonic code. Well, there is no difference between this one and group coding system. The only difference is that the letters used in the code, once the letters are used in the coding system, it is called mnemonic coding. Well, let's see them one by one. Sequence coding. In a sequence coding system, the records are simply numbered in sequence. The the system is essentially the same as the counter primer key discussed earlier. Sequence codes are typically used to identify transactions or events. Sales invoice, purchase orders, and checks are examples of business documents where sequence codes are employed. An advantage of sequence codes is that missing documents can be quickly identified, either manually or by a computer system. But in the sequence coding system, it is not possible to indicate categories of items being coded. So, a sequence code for sales invoice would not be able to distinguish between, for example, East region invoice and West region invoice. Well, but in block coding, a block coding system, that means ranges of numbers are reserved for each category of the items being coded. And similarly, we have the group coding. In a group coding system, each digit or group of digits in the code for an item signifies a different aspect of that item. Well, for example, let's consider the coding system for the parts. Digits 1 and digit 2 indicate the division number. Digit 3 indicates the warehouse number. Digit 4 and digit 5 indicate the part number. Digit 6 through 8 indicate the specific part number. So, if we have the part number of 163599217, we know it indicates that this part belongs to division number 16, stored in the warehouse number 3, is of part type 59, and that is and with the part number 213 in that warehouse. So group codes can be a very flexible coding system. And since there's no theoretical limit on the length of coding and the number of dimensions that it can be used to capture. But practically speaking, the group coding should be of reasonable length so that it is not too long or too burdensome for the users. And lastly, let's see, if the letters are used, a coding system can be the mnemonic, either in its entirely or a part. So this coding system is one that is suggestive of the items being coded. The two-letter state code used by USPS is a good example of this coding system. For example, IN suggests Indiana. TX suggests Texas. CA suggests California. And NJ suggests New Jersey. Well, etc., etc. In the part number group codes described above, rather than using numbers, two meaningful letters could be used to indicate the division. For example, the letters NW could be used to suggest that the part belongs to Northwest division. So in summary, the choices for coding system are sequence coding, block codes, and group codes. Group codes can be made mnemonic letters in the whole or in the part, such that the code itself is suggestive of what is being coded. So let's take a look at some of the guidelines of the coding system. First, the use it is better to use numbers rather than the letters whenever possible, because numeric codes are easier to be entered into a computer system. Secondly, you need to allow for future expansions. For example, if you have only first two digits to indicate your division numbers, you have to assume that you have no more than 99 divisions. But what if your company expands, which includes more than 99 divisions? You have now 100 divisions. So in this case, your coding system cannot be expanded if you choose to use only two digits to signify your division numbers. And lastly, you need to make the code as simple as possible. So next, let's use this example to illustrate these three coding systems. Assume your institution would like to devise a coding scheme for identifying the students. Students can be in-state, out-of-state, or international students. Further, in each of these categories, students can be either undergraduate or graduate students. The institution has about 10,000 students. There can be over 1,000 students, but less than 4,000 students within each subcategories. So in a block coding scheme, scheme, that scheme could be devised for identifying students like this. For the 00001 to 04999, it means in-state undergraduate. And all the way to the end. For 25000 to 29999, it means international graduate student. So, given a student number, you can know the category of that student. For example, if you are given 06000, you know that student lies into the second group. It means in-state graduate students. But if you use a numeric group coding system, well, you can define that the first digit of that student number could indicate that student is in-state, out-of-state, or international, where 1 signifies in-state, 2 indicates out-of-state, and 3 indicates international. The second digit represents undergraduates or graduates, where 1 indicates undergraduates, while 2 indicates graduates, and the digits 3 to digits 6 indicates the specific student number. So if you are given a student number 120875, you know that number indicates this student is an in-state graduate student. And similarly, a student number 211278 would be out-of-state undergraduate student. Well, we can use mnemonic group coding, where we can use S indicates in-state, O indicates out-of-state, and I indicates international. So actually, this is no difference from the numeric group coding scheme. The only difference is that we use a ladder to indicate the category of each digit. Well, for the first digit, we use S, O, or I to indicate in-state, out-of-state, or international. And in the second digit, we use letters U. We use letter U to indicate undergraduate, and the letter G to indicate graduate. So the SG student indicates in-state graduate student, while the OU student indicates out-of-state international student. Well, that is okay. That's all of the concepts introduced in this class. So in the next class on Wednesday, we will continue our discussion from file types. So if you have any questions, please let me know. And I will see you on this Wednesday. So bye-bye.
Hello, Professor. How are you?